All right, 4.6, Similarity and Transformations. The first thing to know, similar figures. Similar figures have angles that stay the same. Angle measure. The angles don't change. Degree measure. Sides are proportional. And if you've been studying dilated figures are always similar to each other. So a figure that's been dilated, an image or a preimage that's been dilated, will be similar to its image. Okay, so maybe make a note. Preimage is similar to the image. Okay. Okay, so angles stay the same, and we should probably put measure there. Okay. All right, so I've graphed a triangle here using the graph of the polygon. Use the graph of the polygon to graph its image after the similarity transformation. So really what we're doing here is we're taking a preimage, and we're going to dilate it and then translate it or rotate it or reflect it. Or we're going to reflect it, rotate it, or translate it, and then dilate it. So we're going to do one of the three rigid motions as well as a dilation. Okay, so this one, we have the triangle A, which is at coordinate 2, 4, B, coordinate 2, 1, and C, coordinate 3, 1. And we're going to first translate it 5 units to the right, or excuse me, to the left, 3 units down. This is our rule here. And then we're going to dilate it from the origin 2 times the value of X, 2 times the value of Y. What I'd like to say is what you should do here is you should really try to use a matrix. Matrices, I'm going to draw one out real quick. I'm going to put these 3 points in it. So in a matrix, we have X and we have Y. And we have coordinate A, coordinate B, and coordinate C. And X is at 2 for A, and the Y value is 4. For coordinate B, the X value is 2, the Y value is 1. So 2, 1. So all of our X is on top, all of our Y is on bottom. And C, 3, 1. Okay, we have a matrix there. And I'm just going to show what I'm going to do or what's happening to each of these points. Okay, so this coordinate, XY, is now going to move X minus 5 for all my X values and Y minus 3 for all my Y values. So I'm going to draw a new matrix, subtract from each X. 2 minus 5 is negative 3. 2 minus 5 is negative 3. 3 minus 5 is negative 2. 4 minus 3 is 1. 1 minus 3, negative 2. And 1 minus 3, negative 2. And what that's done is it has allowed me to see what this preimage, which I've already got graphed over here, would be if I moved it 5 to the right, or 5 to the left, and 3 units down. So notice if I've plotted, so again, this is X and Y, or excuse me, not X and Y. This is A, B, and C, but it's been translated now, so we'll call it primes there. Okay, and so if I were to move it 5 units to the left, 3 units down, it'd be at negative 3, negative 1, or negative 3, 1, excuse me. It would be negative 3, 2. My goodness. Okay, negative 3, negative 2. And negative 2, negative 2. All right, so here would be A prime. Here would be B prime. And I'm not going to actually completely draw it in, but those would be the vertices. Okay, I'm going to just kind of draw it in the best I can here. I'll make it a little easier to see. Okay, so that's after our translation. And now I'm going to go ahead and dilate it. And I'm going to dilate it by a factor of 2. So I'm going to be doing, since they're both 2's, I'm just going to put times 2 right here. And this is scalar multiplication. So really, let me put the times 2 above the arrow just to say I'm multiplying each of these coordinates by 2. So negative 3 times 2 is negative 6. Negative 3 times 2, negative 6. Negative 2 times 2, that should be just a 2, not a negative 2 there. Negative 2 times 2, negative 4. Okay, 1 times 2, 2. Negative 2 times 2, 4. Negative 2 times 2, negative 4. Okay. So my A prime prime, B prime prime, and C prime prime. Okay, would be at the order pair negative 6, 2. And let me go ahead and switch colors here. We'll go ahead and say this one is this color here. Okay, negative 6, 2. So we go negative 6, positive 2. We are now right there. Okay, negative 6, negative 4. So negative 6, negative 4. We are now right there. So A prime prime, B prime prime, and then negative 4, negative 4. We are right there. Oops, there we go. C prime prime. So good, good, and good. Okay, so there we got it. Let's fix that one there. All right, a little better. So notice that my dimensions have changed. So what was a length of 1 from B to C, so from B prime to C prime, or B prime prime to C prime prime, is now 2. Why? Because we dilated it by a factor of 2. What was 3 from AB, from A prime prime to B prime prime, is now 6. So the sides are proportional. This was 3, it's now 6. This was 1, this is now 2. Okay, so we still have the proportionality. It's been dilated from this place right here, from the ordered pair. So we slid it, and then we dilated it. Here's our end result. A lot of times it's just good to kind of shade your final figure. Some teachers like that. Just makes it easier to see. All right, there we got it. Matrices help out. I really like using them, so that's what I'm going to do here. Okay, let's go ahead and try a different one. Use the graph of the polygon to graph its image after similarity transformation. So here are the coordinates. It's already graphed for us, A, B, C, D. We have a dilation centered at the origin. X, Y is going to be 1/2 of X and 1/2 of Y, and then we're going to reflect over the Y-axis. So the first thing I'm going to do is I'm going to put everything into a matrix. So I have my matrix here. Once again, X, Y. Okay, we have A, B, C, D. I'll go a little faster this time. Okay, so 6, 8, 10, 4, 6, 0, 2, 4. Okay, we are going to dilate it by 1/2. We're going to multiply everything by 1/2. That's called scalar multiplication. 6 times 1/2 is 3. 10 times 1/2 is 5. 3, 2 times 1/2 is 1. 8 times 1/2 is 4. 4 times 1/2 is 2. 0 times that's 0. And there's 2. Okay. All right, so that's the first step. And now I'm going to go ahead and continue that. I'm going to reflect it over the y-axis. Now just keep in mind, a reflection over the y-axis, when we do that, our x value, what was x now becomes negative x. And what was y stays y. So for instance, if I reflect point D over the y-axis, now I'm just showing this as an example. This isn't part of the problem, but if I were to reflect this over, it ends up here. Okay? So y didn't change, but my x was at 2, and now is at negative 2. So this is 2, 4. This is negative 2, 4. So x became opposite, y stayed what it was. So really, when I'm doing this, I'm just saying, okay, I want negative x and y. Those are going to be my values now. So this is going to be negative 3, negative 5, negative 3, negative 1. Y doesn't change. Okay, and usually I wouldn't show it like this. I would actually show it like this, negative x, comma, y. I just leave kind of a trail of what I'm doing. That's the reflection in the y-axis. So here's A prime, B prime, C prime, and D prime. Notice I'm just using primes this time because I'm not going to graph the intermediate. So I'm not going to double prime it here. I'm just going to graph the final. So we go negative 3, 4. There we got it. We got, that is A prime. We've got negative 5, 2. There is B prime. We have negative 3, 0, C prime, and negative 1, 2. Oops, you know what? That is not negative 1, 2. There's negative 1, 2. There's D prime. So good, good. Oops, let's hit the point. A little better. Okay, all right. There we've got it. Okay, so we've dilated it and then reflected it. All right, let's go ahead and try another one here. So far we've done a translation with the dilation, a reflection with the dilation. Now we're going to do a rotation with the dilation. Okay. And so once again, same idea. Here we're going to go ahead and find it. I'm going to use a matrix X, Y, A, B, C. Got 2, 4, 2, 2, 6, 2. Okay. I am going to rotate it 90 degrees about the origin. Remember, if you remember your rules for rotation, that what was X becomes your opposite of your Y value, and what Y was Y is now your X value. Okay, so that's how it switches about. So we're going to actually now get the order paired negative YX. Okay, and so X becomes your Y. So we now have 2, 2, and 6. Okay, these just switch down, and then we our X value is actually the opposite of Y. So negative 4, negative 2, and negative 2. Okay, so just notice your X's became your Y's. Your Y, the opposite of your Y's became your X's up here. Okay, and then we're going to go ahead and do some scalar multiplication. Multiply each value by 3/2. And when you're doing multiplication, multiplying by a fraction, you're multiplying by the numerator and dividing by the denominator. So don't let that freak you out. So negative 4 times 3 is negative 12 divided by 2 is negative 6. Negative 2 times 3 is negative 6 divided by 2 is negative 3. Negative 2 times 3 is negative 6 divided by 2, negative 3. Negative 2 times 3, or 2 times 3 is 6 divided by 2 is 3. A lot of 3's here. Another 3. And 6 times 3 is 18 divided by 2 is 9. Okay, so we have now A prime, B prime, C prime. Okay, and so A prime is at negative 6, 3. B prime, negative 3, 3. And C prime, negative 3, and 9. And there we got it. All right. So we rotated it 90 degrees, and then we went ahead and dilated. Okay. So let's go ahead and try something else here. We're going to actually look at some sketches now. So describe the similarity transformation that maps the preimage to the image. Okay. So now we're given a preimage. Notice this is our preimage, the bigger one, because it goes from A to A prime, B to B prime, and C. Okay. So first thing you want to do is probably figure out if it's an enlargement or a reduction. And so this is going to be a reduction. Getting smaller. Okay, that will help you in terms of your dilation. Okay, and then some strategies. First, look at the orientation. If it changes orientation, then that means a reflection has occurred. Okay, and so if you're not sure or can't remember what orientation is, that just says when you're looking at your points from A or alphabetical order, do they go clockwise or do they go counterclockwise? Okay, so in other words, when I read A, B, C, D, notice those points are going in a clockwise fashion. A prime, B prime, C prime, D prime, those are also going in a clockwise fashion. Therefore, this shape has not changed orientation, which means it has not been reflected because it did not change orientation. So in this case, no reflection. Okay, which means I know I obviously changed size, so I have a dilation. Okay, it just means that I either rotated it or translated it. Those are the two things that I could have used. I didn't use a reflection. So the next thing I'm going to do is I'm going to try to make the shapes the same size. So I'm going to look at proportions. What I mean by that is, let me go ahead and switch colors. When I look at side lengths, so notice this length right here, and I'm just going to count diagonal lines here. I realize that this is not completely accurate, but you have 1 diagonal, 2 diagonal, 3 diagonal, 4 diagonal. It has a slope of 1, so it's perfect there. You could also calculate slope, which would be a little more difficult here. But that would be like 4 diagonals, and this has a length of 2 diagonals. This has 4 diagonals, that has 2 diagonals. This has 4 diagonals, that has 2 diagonals, okay? And same there. So really, these sides are proportional, okay? That means I can I can try to get a scale factor going here. Okay, so I've got the same size. Let's go ahead and look at my scale factor. So this is 4, this is 2, this is 4, excuse me, this is 2. Okay, if I'm counting diagonals, I know that's not the actual length, but I'm counting diagonals, 4 to 2, that means I have cut this AD in half to get A prime D prime. So I want half of AD, okay? So the first thing I'm going to do is take half here. So when I go a dilation, of 1/2 from the origin. Okay, so I'm going to go ahead and dilate it at 1/2. So I'm going to go, when I do that, this D, that was 2, 4, so I'm going to go ahead and put that point there, 2, 4, is now going to be half of 2, which is 1, 1, and half of 4, which is 2. That is going to be my new point. I'm just going to put X's where those are, okay? And then C, which was at 6, 0, is now going to be 3, 0. Okay, B, which is at 10, 4, is now going to be at 5, 4. Oops, excuse me, 5, 2. And it's kind of right there in the middle of what I have there. And then A, which is at 6, 8, is going to be at 3, half of that, and 4. So right there. Okay. So I have my new figure right here. You'll notice now, if I kind of look at that red figure, after I dilate it, it's there. Now to get this, which by the way, that would be like D, C, B, and A. To get this figure to lie on top of this one, I have to, let's just pick point D. I'd have to go up 1, 2, 3, 4, 5, 6, and to the left 1. So up 6 and back 1. So what that looks like is a translation up 6 and back 1 is X minus 1, that's the back 1, and Y plus 6. Okay? And we should actually write that in the correct format. So I guess that would be a translation XY, X minus 1, Y plus 6. That's the actual correct format. Or if you used component format, that would be -1, 6 in component format. Okay, using your vector kind of notation. Okay, so there we did it. All right, let's try a different one here. Describe the similarity translation that maps the preimage to the image. So let's look for a reflection first. Okay, so OD, or let's go BCDO. Okay, so we're moving in this orientation. Okay, in a clockwise fashion, and then BCDO, once again also clockwise. So we do not have a reflection here, so no reflection. Okay, and so the next piece is try to make the shapes the same size, looking for proportions. Well, I look at this and it makes it pretty easy. If this is my image, and this, or excuse me, if this is my image, this is my pre-image, I'm going to have to make my pre-image bigger. Okay, and if I look at proportions, I go, well, this side has a length of 3 from O to D, from O to D prime. That has a length of 6. So it looks like I'm going to have to double in size, and I can double check that here. Here's 2, and here's 4. Okay, yep, I'm going to have to double in size. So the first step is to do a dilation. Okay, of 2 from the origin. Okay, and so when I do that, let's go ahead and we'll use this color. Okay, so what was 3 is now going to move 6 away. That's going to be my next shape. or my D prime here before I move it. I guess I should use D prime prime since I already used D prime here. Okay, and then 2 will now be double that, or 4 away. So that'd be B prime prime. Okay, and then notice this coordinate right here. The coordinate of C is at the ordered pair 2 and looks like 2, 3. Okay, so 2, 3 will now double, so that'll be 4, 6. So we'll go 4 and 6 right there. And there is C prime prime. Okay, so if we sketch that in now, all right, you see your shape. It's now the correct size. All right, so now you have to figure out how are you going to get this double prime to these single primes here. Well, it appears as though I could just rotate it. Okay, so if I rotate it, looks like I'm going from this coordinate right here, which is at 4, 6. That's C prime prime to C prime, which would be -4, -6. And if you know your properties of rotations, that's 180-degree rotations when your X value and your Y value just become opposite. Okay, so this is a rotation. Okay, 180 degrees about the origin. All right, and my handwriting is just getting sloppy here. Let's fix that up a bit. I know it's not perfect, but there we go. So those are our two transformations there. Okay. All right, one more. Let's try one more here. Okay, we're going to go ahead and describe the similarity transformation that maps the image to the preimage. So let's go ahead and look for, in this one, let's look for orientation. So ABC, this one moves counterclockwise, and ABC, that one moves clockwise. Okay, so this is a reflection. Okay, the orientation changed, so we have to use a reflection here. So we know for a fact, we're going to use a reflection at some point. Okay, and we're also changing sides, so we're going to also use a dilation. Okay, and so let's go ahead and look at the dilation. If we're looking at side lengths, this is 2 from B prime to C prime. B to C is 4. A to B is 2. A prime to B prime is 1. So it looks like we're cutting it in half. So dilation of 1/2 from the origin. Now I've done all these from the origin. Sometimes if you go from the origin, you may have to also do a translation in there in order to get it so you can reflect or rotate. But we haven't had to do that. You won't have to do that in any of these sections. So we're going to dilate it 1/2 from the origin. So first step is to take B, which is at the ordered pair of 2, 2, and we're going to now move it, cut 2, 2 in half to be 1, 1. So that would be my new point B, and I'm just going to put X's there. A, which is at the ordered pair 2, 4, we're cutting both of those in half. It's going to be 1, 2. So that would move us to there. Okay, and dilating 1/2 again, C, which is currently at the ordered pair 6, 2, is now going to be at 3, 1. Okay, and so you see those X's. If I connect those X's, that's my new shape. And now from there, you can see I'm just reflecting. This is A to A, B to B, and C to C. It's just a reflection over the Y-axis. All right, there we go. Okay, so just a couple strategies there. I think that's all I've got for you. Good lucky.